Hello, my friends. Welcome back. We are looking to enhance the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. Now, Fractals and Recursion is this very interesting project through which we learn about recursion by making fractal patterns. For example, the one that I'm showing you here. Now, in this video, we will see an enhancement where we will not change the output of the code, but we will change the way the code is written for the square pattern. So what I mean is, we are going to enhance this code by looking at, basically the square code. You notice that right now it takes X, Y, and L as an input, but it turns out that it's more flexible to do it like what we have done for the tree, where we will create levels. So for example, level one is, the big square, level two is the smaller square, level three is the next smaller squares, and so on and so forth. So we will, change the way the arguments are given. We will create an argument called level. Now that, as I said, makes it more flexible, and later on we'll see the usage for this as we move forward. Now you notice that the way this argument L is used is that it controls the size of the different squares, which means that if I can create a list of these sizes that I want, then I can use level as an index into that list, and again the same outcome will be achieved. So that's exactly what I'm going to do. I know that my sizes, for example, when I call minus 100, 200, my square sizes go from 200 to 100 to, because of this L by 2. So I can just go and say, look, basically, let me create a list here. Let's just call it, let's say, L list. Now, what I mean is like list of lengths. And, I'll use list comprehension here to, let's say, do this. So I'm just going to say it's 200, square brackets. It has to be list 200 times, say, 2 to the power of n, for n in range, let's say 0, 6, and -1. Now, this is very interesting. Basically, we are saying start at 0, go until, sorry, it should be 0, -6. So start at 0, go until -6 in steps of -1, which means 0, -1, -2, -3, -4, and -5. That's because I have level 1, level 2, level 3, level 4, level 5, and level 6. So, I have 6 levels in there, and that's what I'm trying to reflect. Of course, you can do more levels, having done this, but I'll just create it like this. And really, all I need to do is to say that, okay, look, when I get into the program, I need to, of course, find out the value of L. So I'm just going to say L is equal to L list, let's say level, because, level will now be an argument. So I make level as an argument, and I say, okay, look, when the level is 0, go and look at the first value of L list, and so on and so forth. Having done this, now I want to do 6 levels in this, let's say. So I just go and say if level is less than 5, 0, 1, 2, 3, 4. So, if that's when I do a recursion, I will go and say, okay, let me just do this with level +1. So, it's becoming quite similar to what we do, for example, in the tree code where I do level -1. So here I'm starting at 0, and I'm going basically, 1, 2, 3, 4. Until 4, I do a recursion, which means I call this function once with 5, because when level is less than 5, which means at 4, I go and call this function with 5, and hence this list is still intact. I mean, there's no error, let's say, created on this list. Now we can see this working. Let's just, see this working. Of course, I will now call this not with, let's say, 200, but in fact, I'll call this with, say, 0. So which means 0th level is what I'm creating, and I get exactly the same outcome. You notice the code goes exactly the same, and I get the same outcome. Let's look at what is L list. Well, L list is 200, 100, 50, 25, 12.5, 6.25. Again, because remember, L list is done by list comprehension, we are basically saying, well, start from 200 times, let's say, 2 to the power of 0, 200 times 2 to the power of -1, 2 to the power of -2, and so on and so forth, which is what we are saying. Now, in case you want to make this, let's say, bigger, well, I can go, for example, 250 times this. So this is that way, it's somewhat flexible. Of course, when I'm changing these numbers, then you may want to change the X and Y starting point as well. So let's just try that. I can see this running now, by putting the square at -125, -125, starting at 0. When I do this, you notice that the squares are bigger because the first square was now 250 in size. So it's actually very similar to what we had been doing. But it's just a little bit more flexible, as we'll see. In fact, this gives us a lot of, we can use this quite effectively in some of the later enhancements. Now, before I wrap this up, let me just say that, okay, let's say what happens if I want to do more levels here, right? So I can definitely do, let's say, two more levels. So I just go and say, well, maybe make it until, let's say, -8, so 0 until -7. But here what it means is that I'll also make this go until, let's say, I'm going to call it until 7, because I just must make sure there is no error over here. So I just increase this also by 2. So now I run this. Let's say this time I again do this. um, you notice the recursion starts, and I'm going a lot deeper. The squares are becoming quite small, right? So that it's like barely becoming like a dot, right? But you get the idea that I'm actually going deeper in the recursion, and that's how this whole thing is in fact working. Yeah. um, you can see it getting completed, quite nice to look at, right? But those squares have become really, really quite small. So I could have started with something bigger. In fact, we can try that. Maybe if I start with, let's say, instead of 250, let's say I start with, let's say, 350. And let's just do one more experiment while we are at it. Let's say if I were to do this in a reverse manner. Now, the only thing I have to watch out for is that my L gets formed beforehand, because my this command is going to require L, right? So I just do it right after assigning L with the level, and pretty much that's it, right? So let's say I just go and say, let's say -175, -175, and 0. And remember, we are doing it in the inverted order, so the recursion is happening in the different order. But you see that the end outcome is exactly what we had expected. It is in fact starting to form up exactly the same way. Very, very beautiful to look at. Very good to think about what's going on in the code. And that's the point, right? That when we build fractals like this, the whole learning of recursion becomes visual, which I think is quite powerful. So now our recursion is complete. In fact, we're doing several levels, right? So get the idea that now it's much more flexible. But before wrapping up, I'll just go back to my original style. So which means that we'll first draw and then we'll call the recursive function. Like we said, the two will result in the same end outcome, though the order is a little bit different. I hope this was interesting to you. Methodology of building projects and then looking at enhancing them is really powerful, because it makes you analyze code in detail. It makes you understand how things are actually working and how things can be made better. Look at our website www.ybyte.in, because that is how we learn Python programming, through these fun activities. Take care. Thank you so much. Bye bye.